Let's move to the computation part. We're going to use the Gressa format in solving the potential and kinetic energy problems. Of course, G stands for our given, and R is the required or what is being asked in the problem. And we need to write down the equation or the formula to be used, and S for our solution. And letter A is for our final answer. Here we have the first problem. You throw a ball with a mass of 2.1 kilogram. The ball leaves your hand at 30 meters per second. The ball has blank energy. Calculate it. The very first thing that we need to do is to analyze the problem. Thinking of that you are holding a ball. Meron kang daladalang bola na may bigat na 2.1 and you throw it sa bilis na 30 meters per second. Meaning, from being stored in your hands, there is a potential energy. You release it using and applying a force. Therefore, the ball moves. And the ball has kinetic energy right now. So that the things that we are going to calculate is our kinetic energy. But here, we need to write out our given. First is our mass, which is equivalent to 2.1 kilogram. Then velocity, which is 30 meter per second. And our required right now is KE or kinetic energy. And the equations that we're going to use is KE is equal to the product of mass times velocity squared divided by 2 or 1/2 mv squared. Okay, then the solution. KE or kinetic energy is equal to the mass. What is our mass? All you need to do is to substitute the given to the equation or to the formula that we're going to employ right now, which is 2.1 kilogram for our mass. Multiply it to our velocity, which is 30 meter per second, and we need to square that. And all in all, we're going to divide it by 2. Okay. Then, let's make use of this. Okay. Since we're looking for KE, right? KE is equal to 2.1 kilogram. That's it. And you need to multiply it to velocity. The very first thing that you need to do is to multiply the velocity to itself. It doesn't mean that you're going to multiply 30 times 2. That is wrong. So all we need to do is 30 times 2. That is squaring an integer or a number. So meaning we have 30 times 30 is equal to 900. Yes, exactly. That's correct. 900. Since we squared, we also squared the meter squared, and also the second squared. Since all are being squared, then divided by 2. So that's it. Then it is equal to 2.1 times 900. So we're going to multiply the two variables. 2.1 times 900 is equal to 1,890. Then copy the unit, which is kilogram. Okay. Then meter squared and second squared. Okay. Then divide it by 2. So that's it. 1,890 kilogram meter squared second squared divided by 2 is 945. All right. 945. And of course, all you need to do is to copy the units. Kilogram. Then meter squared second squared. Okay. Looking here, we can now identify that this unit is just the same with the work. Since work, sabi natin before, work is equal to force times distance or displacement. Since force is equal to Newton, then distance is equal to meter, work is equal to, this time it is equal to Nm, or what you call as joule. Alright. So joule ang ating gagamitin, Nm or joules. So meaning, we have the N. According to our previous lesson, N or Newton is equivalent to 1 Newton is equal to 1 kilogram meter per second squared. So that's it. 1 Newton is equal to 1 kilogram meter per second squared times M. Alright? So minultiply pa natin siya ng M. So we are multiplying same units. Therefore, we can now get the same units here as it is. Alright? So meaning, kilogram meter squared or second squared, the same with the units of work, which is equivalent also to joules. Therefore, we can now say that kinetic energy for our final answer is, kinetic energy right now is 945 joules. So that's it. It is just the same units with work and energy. All right. So that's it. We're going to look at in our first problem. Okay. So that is for kinetic energy. Let's proceed with the next. Next problem here is, there is a bell at the top of a tower that is 45-meter high. The bell is 45-meter high and it weighs 19 kilograms. The bell has blank energy. Calculate it. Again, let us analyze the problem. Sa taas ng tower ay merong bell na 19 kilogram ang bigat. At ang tower mula sa ground ay may taas na 45 meter. So, ibig sabihin, hindi naman gumagalaw yung bell at nasa taas lamang in position. Therefore, the bell has potential energy, specifically gravitational potential energy, and we need to calculate it. Okay, let's proceed. What is our given, or what are our givens? We have, how about 45 meter? So that is the height. So h is equal to 45 meter. And the bell weighs 19 kilograms. So we're talking about the mass, which is 19 kilogram. And of course, since we're talking about gravitational potential energy, there is a constant for acceleration due to gravity, which is 9.8 meter per second squared. Okay. So kompleto na ating given. Then what is our required? Since we're looking for potential energy, then PE is our required. All right. And the equation or the formula to be used. PE is equal to mgh, or simply that we're going to get the product of the mass, then acceleration due to gravity, then times it or multiply it to the height. Then the solution. All you need to do is to substitute the given so to our equation. PE is equal to what is our mass, which is 19 kilogram. Okay, 19 kilogram. And our acceleration due to gravity is standard. When we say standards, it is constant. Hindi na yun nagbabago, which is 9.8 meter per second squared. Okay. Then our height is 45 meter. That's it. So we're going to get the product. And our answer right now is, we're just going to multiply it all. 19 times 9.8 times 45 for the height is equal to 8,379. 8,379. Then copy the unit, which is kilogram. Okay. Then bring down M. Since we are going to multiply the same units, so we're going to add the exponent of it. So meter plus meter is equal meter squared. Then second squared. That's it. Then our final answer is PE is equal to 8,379 joules. All right. So that is our answer. So for us to write it down dito, so we have 8,379. Para makita natin, that is exponential yung ating numbers dito. Meter squared and also second squared, or simply 8,379 joules. So that is correct. Okay, all in all, here we have our problems for kinetic and potential energy. Hoping that you have learned in our lesson. Thank you and God bless.